Good day, viewers. You are welcome to Abeokuta Grammar School online teaching. Akisanya Abiodun by name, and I will be taking mathematics. The topic for today is Standard 4. Last lesson we were given some questions as assignment, which I'm going to take the correction on now. So we have the first one. 2, 5, 6, 0, 1, 3, 5, 5, 0. We have to take this to standard 4. And if we can recall, we said last lesson that when the number is asked to take it to standard 4, it has to be in the format of the original number being reduced to a number between 1 to 10. So that means we have to reduce this number to a number between 1 to 10. And so having that, from what we did last lesson, we have 1, 2, 3, 4, 5, 6, 7, 8. So this gives us 2.56, 013, 550 times 10 raised to power 6, because we move it forward 8 times. We move it forward 8 times, and so that means 10 raised to power 8. Then for the second one, we have 7. 7 you can see is already in standard form because it has conformed to the rule of standard form. It's between 1 to 10. And so, just writing it in that format of standard form, that means our 7 is going to give us 7.0 times. You can see we do not move the decimal point at all. We just have 7.0. So that means times 10 raised to power 0 because we do not move the decimal point at all. Then for the third one, for the third question, we have 1, 0, 0, 0, 0, 0, 0. Here we have 1 million. So to reduce 1 million to standard form, we have to move the decimal point. What's that we're doing? 1, 2, 3, 4, 5, 6. This gives us 1.00, or you can just have it 1.0. These other zeros are inconsequential since they are zeros. So times 10 raised to power, the number of times we move forward, and that means 10 raised to power 6. Then, the fourth question, you are asked to take to ordinary form. Take to ordinary form. And so we have this question under that. 8.21 times 10 raised to power 5. Now, taking that to ordinary form, that means we have to change it back to the original form it was before taking to standard form. And so, in doing that, our 10 raised to power 5 is as good as 10, as in 5 zeros, which gives us 100,000. So, multiplying that with this, it will give us 821. The 5 zeros, then to put the decimal point 1, 2, 2 figures at the back of decimal point 1, 2, which cut off 2 of the zeros. So eventually we are left with 8, 2, 1, 0, 0, 0. And that is the number in ordinary form. And then the last question we have for the assignment is 7. That's number 5. 7.6 times 10 raised to power minus 2. So, changing that to ordinary form, we have 7.6 as we said last lesson. Our 10 raised to power minus 2 from lots of indices can be converted to 1 over 10 raised to power 2. And so, that gives us with 7.6 times 1 over 100. So, working out this, we have 7.6 over 100. And then changing that one to decimal number. 2 zeros here, just move your decimal point 2 times forward. That gives us 1, 2. So we have 0.076. So those are the things we did last class. But for today, we are going into addition and subtraction of numbers in standard form. When we have questions that are already in standard form and it now involves addition and subtraction, how do we go about handling such? That is the objective before us today. How we handle problems that deals with addition and subtraction of numbers in standard form. So I'll take some example of this. I'll see how we go about doing that. Example 1. You have it 3.4 times 10 raised to the power 3 plus 6.2 times 10 raised to the power 3. Now, if you look at this problem, you see that we have plus there. This is a number in standard form and another one in standard form. There are two ways through which we can handle this. There are two methods through which you can handle it. You can change the number in standard form to ordinary form first, whereby you now proceed on to add them together, and the solution you come up with you now change to standard form. So I'll first take the first method. First method of doing that. And we said the first method we want to learn now is changing to ordinary form first. So changing to ordinary form. And so we want to handle this. Our 3.4 times 10 raised to the power 3 is as good as 3.4 times 1000. And when you do that, to give you 34000, one figure at the back of decimal point, cut off 10 from this. And so we are left with 3400. Also, we have 6.2 times 10 raised to the power 3. Just as we did this, you have 6.2 times 1000, leaving us with 62000. 10 is cut off because of this at the back of decimal point, and we are left with 6200. So now that we have this, we now add up the two numbers in ordinary form. We go on to add up the two numbers in ordinary form, and when we are through with doing that, we now change our answer to standard form. So, adding up now, we have 3400 plus 6200, and that will eventually give us 0069. So it gives us 9600, and then we have to change our 9600 to standard form because the question is given in standard form. And so we will now be left with moving the decimal point from the back forward 1, 2, 3. That means we have 9.6 times 10 raised to the power 3. That's the first method. Now, another way through which you can solve this problem is by factorizing. Factorizing the question given in standard form. So I'll take the second method. Second method. For the same question now, just to see if we arrive at the same thing. We have the 3.4 times 10 raised to the power 3 plus 6.2 times 10 raised to the power 3. Now, I said the second method has to do with factorizing, using the factorization method. Now, what do we mean by factorizing it? When we say we want to factorize, that means we are looking for what is common on both sides. So, looking at this one standard form number, and this another one. So, factorizing now, the thing that is common to both of them is 10 raised to the power 3. So, we bring out that which is common. So, we have 10 raised to the power 3, open a bracket. On this side, we are left with 3.4. So, 3.4 plus, also on this side, you can remember, we are taking out 10 raised to the power 3. So, So we are left with 6.2. And that leaves us with 3.4 plus 6.2 will give us 9.6. So eventually we have 9.6 times 10 raised to the power 3. Now, if you look at the two answers we arrived at, you see that we arrived at the same thing. We arrived at the same answer. But if you look at it critically, you will find out that this method is shorter than the first one. Anyway, you can use any method that you are comfortable with. It's only that one is faster than the other one. So let's take another example of this. Still on addition of number in standard form. Let's take another example, example 2. Let's say you are given a question like this: 8.63 times 10 raised to the power 5 plus 4.38 times 10 raised to the power 3. Now, you look at this one, it's a bit different from the first one we had. The first one we had, the 10 there has the same power, which makes it so easy to factorize there. But if you look at this one has 10 raised to the power 5, while the other number has 10 raised to the power 3. Also, we can still go ahead to factorize. I'm limiting myself now to just a method. You can apply any of the methods you so wish. So for this one, I'm going to use the factorization method also. So like I said, this is one number, this is another number. Now, if you want to factorize, we said factorizing means bringing out that which is common to both sides. So that which is common is still the 10 raised to the power forever. So in this case now, 10 raised to the power 5, 10 raised to the power 3. For both of them, that which is common is going to be 10 raised to the power 3. We can have 10 raised to the power 3 from 10 raised to the power 3, then 10 raised to the power 3 from 10 raised to the power 5. So, bringing out that which is common, we have 10 raised to the power 3, open bracket, 8.63 times, now your 10 raised to the power 5, we only brought out 10 raised to the power 3. That means we'll be left with 10 raised to the power 2 here. Don't ever forget to put that. So 10 raised to the power 2 plus, here now we are left with 4.38. And so, if we handle this, we have 10 raised to the power 3. This one now, 8.63 times your 10 raised to the power 2 is the same thing as 100. Plus 4.38. So, 10 raised to the power 3. If you solve this, we have 863. We multiply 8.63 times 100. That will give us with 863 plus 4.38. So adding up, we have 10 raised to the power 3. So we have 867.38. And so we have 10 raised, and we now have 867.38 times 10 raised to the power 3. But mind you, this question is in standard form. So looking at our answer here, we have 867.38, which has not conformed to the rule of standard form. That is, that the number should be between a number, it should be a number between 1 to 10. And as such, that means we have to take our answer to standard form. You can't leave it here. So we have to take 867 rather, 0.38 times 10 raised to the power 3 to standard form. And doing that, that means this 867 has to be reduced to 8 point something. So we have to move this decimal point from here forward. 1, 2. Which will now give us 8.6738 times 10 raised to the power 2. We move this one forward 2 times. 10 raised to the power 2 times 10 raised to the power 3. And so we are left with 8.6738 times 10 raised to power. Under lots of indices, when you have multiplication and you have powers like this, you add the powers. So 2 plus 3 giving us 10 raised to power 5. And that's our final answer. So that is that on addition of numbers in standard form. That is that on addition of numbers in standard form. Now we move on to subtraction of numbers in standard form. Now, these two are almost the same. It's only the signs that are different. The way of handling problems on this with that of addition is the same. It's only that for subtraction you have the negative sign. So I'll take some examples and we'll see how we go about doing it also. So we have it, example 1 on this. We have it 9.37 times 10 raised to power 4 minus 6.51 times 10 raised to power 4. Like I said, you can go through the rigors of changing to ordinary form, subtracting, then your final answer you take to standard form. But just as I did over here, I'm going to use the factorization method since it's faster. Now, solving this, factorizing, you look at it, you have 10 raised to power 4 here, 10 raised to power 4 here, which is common. So using the factorization method, you bring out that which is common. 10 raised to power 4, open bracket, 9.37 minus 6.51. And so this gives us, if we subtract, we have 8.2. And so we have 2.86 times 10 raised to power 4. This is going to be our final answer on this, since this has already conformed to the rule of standard form. 2.86 is in between 1 to 10. And so this is our final answer on this. I'll take another last example of that on the subtraction. So we see how we go about solving it when we have to solve this. So example 2 on subtraction. We have 2.63 minus 9.3 times 10 raised to power minus 4. I've made a mistake, sorry. There's an omission there. 2.63 times 10 raised to power minus 3, then minus 9.3 times 10 raised to power minus 4. Now, we want to handle this also. Just as we did during addition, we look at this problem, it's a bit different from this, in that the 10 raised to power, whatever, the power of the 10 is different in this case. It's not the same as we have here. So, with that, factorizing, we look for what is common. So, that which is common to both of them is 10 raised to power minus 3. We can have 10 raised to power minus 3 out of both of them. And so, bringing out that which is common, we have 10 raised to power minus 3, open bracket, 2.63, nothing is left here. We have brought out the 10 raised to power minus 3, then minus 9.3 times. Now, here, we only bring out 10 raised to power minus 3. So we are going to be left with 10 raised to power minus 1. So times 10 raised to power minus 1. And so that leaves us with 2.63 minus this one, changing. you have your raised to the power minus 1 is for the decimal point to move forward. And so, if you move it forward, because we have raised to the power minus 1, let me do it here. You have 0.93. You have 0.93. So, if you solve that, you'll be left with, you subtract this one gives us 0, this one gives us 7.1. And the final answer is now going to be 1.7 times 10 raised to the power minus 3. This also has conformed to the rule of standard form, 1.7. 1.70 is as good as 1.7. So 1.7 has already conformed to the rule of standard form. So we are going to leave our answer like this. So with that, I want to believe that we are okay with addition and subtraction of numbers in standard form. But there is a particular question that came to my mind. Supposing you are given a problem like this. Let's take that as example 3 under subtraction. Okay, it's addition. Example 3 under addition. Supposing you are given a problem like this, that you have to solve 6.9 times 10 raised to the power minus 2, then plus 5 times 10 raised to the power 1. Supposing you have a problem like this, how do you go about solving that? The reason I want to take this, you see that it's quite different from the ones we have been doing. The other ones we have either the powers to be negative, or positive. But in this case now, you have this one to a power of negative and this one to a power of positive. So to handle this, factorizing this won't be easy. So as such, you take the first method, which is to change both of the two numbers to ordinary form first. So solving this now, that means you say change to ordinary form. So you have 6.9 times 10 raised to the power minus 2. That's the first number there. You want to change it to ordinary form. It will give you 6.9 times 1 over 100. And that eventually gives us 6.9 over 100. Changing it, you move the decimal point 2 times forward. And that gives us 0.069. So that's for the first number. Then the second number there, which is 5 times 10 raised to the power 1. Changing that one to ordinary form, you have 5 times 10 raised to the power 1 is the same thing as 10. That is 10 just in one place. And that gives us 5 times 10, leaving us with 50. So, for the two numbers now, that means we have 0.069 plus 50. And when you add up, you have 50.069. Now, this number has not conformed to the rule of standard form. 50 is above 10. So you have to take this one to standard form also. And therefore, you have to move this decimal point forward one time, leaving you with 5.0069 times 10 raised to the power. We move it forward one time, so 10 raised to the power 1. And that is going to be our final answer. So with that, I believe we are good to go on solving problems that deals with addition and subtraction of number in standard form. But before we leave here, I want to give you some questions to handle by yourself as homework. So, homework for today's lesson. You have to solve this leaving your answer. 1.7 times 10 raised to power 4 plus 6.5 times 10 raised to power 3. Then 2, 3.18 times 10 raised to power minus 3 plus 9.73 times 10 raised to power minus 1. 3. 1.75 times 10 raised to power 9 minus 1.25 times 10 raised to power 9. Then the fourth one, let's say 7.6 times 10 raised to power minus 3 plus 8 times 10 raised to power 2. So I'll leave you to handle these 4 by yourself, and we'll take it up from there next lesson. Also, I would like to remind us not to forget for your feedback, get through to us through this name, agssnronlineclass@gmail.com. And I also encourage us to share with others, with our contacts, so that they too can benefit from this. So see you next time, and God bless.